Good morning. Namaste. Welcome to our Datavedha data science classes, class 104. I hope you guys are doing well today. And we will start with the first machine learning concepts, supervised learning. I am Poornachand Kalyampudi. I have more than 12.5 years of experience in data science and data analytics. I am going to take you through all these nice and very informative concepts in data science with the help of several examples in day-to-day life, and I hope you will understand, you will like it. Please watch out for this YouTube channel, and we will explain all those issues or problems which you face in machine learning algorithms. You can be the new data scientist. Let's start. Machine learning concepts, supervised learning. In the previous three sessions, we have already understood about what exactly supervised learning means and how it is different from unsupervised learning and what we will do based on our supervised and unsupervised learning with respect to machine learning concepts and tools and techniques. Here in this session, we will cover what is supervised learning and how we need to do, what kind of algorithms we are going to implement. I'm going to take you through a nice example without using pen and paper, and it's kind of math behind the supervised learning concepts. And I will take you through Excel, very small example, and then followed by the same similar example using Python code. So you can do it yourself, but that level I will break it down to, and it will be very useful for your machine learning course and curriculum. So, types of supervised learning. We have regression, we have classification. Regression, you must have heard regression, correlation coefficients, correlations, all these words in current scenario. What do you mean by that? And why do we use regression and why do you think of classification? Let's say I will give an example, a standard example of my weight. So it increased over the period. So why it is increased? So why my weight increased is our objective over here. And for that, what I did over the period of time and what are the causes. So that's a as same simple example as you can see in our day-to-day life. So weight is what? It's a value, 73.2, 72.1, so on and so forth. It's a real number. Okay, when I say output variable over here, which is the real value, which means the value is nothing but um, non it ranges um, more than a specific number. It's some for example, between 0 and 1, how many real values do you think they have? Infinite number. The 0.0000001, then 0.000123455, so on and so forth. We have so huge real values. So weight is a real value. And when it comes to classification, will I stop eating junk food from next month or not? Will I stop eating junk food from next month or not? So, yes or no. It's a binary, it's a classification, right? That is the difference. Classification values are a specific numbers. So, yes or no. So, which color will I wear from next week onwards on a regular basis? Red, blue, green, white, yellow. So, 4 or 5 options. So, these are categorical variables, binary categorical variables. We have already discussed in the first session. Okay, so that is the simplest possible regression. So which are the factors that affect my weight to increase over the period? So my weight here is the objective, which is the output variable. That is nothing but that is a dependent variable because my weight depends upon the other variables. Okay, the other variables are independent variables. We call them. They are nothing but eating habits, sleeping habits, eating junk foods, not drinking water, not doing exercise. Those are the parameters. Okay, we call them as independent, right? We'll go. This is the classic definition. We need to identify the relationship between the output variable and the input variable. And we need to define the objective that which is the most suitable function to determine that my weight increases because of these parameters with this much weightage to those parameters. All right. Here we will understand a classic example of a regression using very basic scenarios in an Excel. That is nothing but as simple as writing on a paper and solving it. So different types of regressions we have: simple regression, multiple regression, non-linear regression, right? And these are all things very informative things you can go and follow. And linear regression, that is what we are going to work on at present. Do you need to understand dependent variable? We already understood what do you mean by dependent variable or target variable. Independent variable, the variables based on which we are going to predict the dependent variable. And equation of a line, linear regression line equation, y equals to mx plus c. From 6th class, 7th class, from our basic mathematics, we have been learning the equation of line. And we need to interpret the coefficients. Here y equals to beta naught, which is y-intercept, and beta 1 into x, which is the coefficient of x, and epsilon is the noise or the error. We cannot predict exactly, but there will be an error. We need to minimize the error. That is our objective, our goal, to get as accurate as we can. We can. Okay, so there are several assumptions. I will tell you very simple assumptions. Linearity, we are going to assume that the variables, independent dependent variables, are linear, and if they are not linear, we will apply the transformations. There are different transformations. If we get in detail, you have a log transformation, Fourier transformation. There are other applications, transformations which can be applied on this. Next thing we looking into homoscedasticity, heteroscedasticity. These are all high-level statistical concepts which we are going to learn going forward. You will be see, mean, variance, standard deviation, error, all these things. So you need to make sure that the variance of the errors should be constant across all levels of the independent variables. We will look into them. And normality of residuals. So the residue function, so the epsilon, the noise, the leftover values. If you plot at each and individual y variables, they will be plotted under a normal, they follow normal distribution. That is the assumption which we are saying. And no multicollinearity. What do you mean by multicollinearity? Multicollinearity. So there should not be there should not be direct, easy relation between the or among the independent variables, not dependent variables. I say I eat biryani every day. I eat rice every day. So eating biryani, eating rice, if they follow the same pattern. So let's say if I eat one bowl of rice, two bowls of biryani every day. So eating biryani is following one pattern, eating rice follows another pattern, but they are very similar. This is as same as X. Let's say X1 is eating biryani quantity, X2 is eating rice quantity, and x1 and x2 are directly related, which is x2 is nothing but double of x1. Okay, so they are collinear, multi-collinear. We should not have those kind of variables. We need to drop those variables if they have inner linear regression. So that is the assumption. And same thing, limitations. We do have several limitations in linear regression. We will look into it. We will understand what kind of assumptions why it violates all those assumptions. If they violate, that will be our limitations. And again, sensitivity to outliers. Suddenly, my weight it gradually increased from 57, 60, 58, 59, so on, 72. Suddenly it became 99 and suddenly it became 50. So these are the outliers. These are not following patterns. You need to handle those outliers properly. And then overfitting and underfitting properly. The line, whatever we are predicting, if it is overfitting and underfitting, we need to understand what kind of issues we are going to face. Okay, let's go down to our a simple example. Okay, here the idea is to see to predict number of umbrellas sold based on the total number of rainfall. This data is synthetic data which I have generated by my own. So I'll just delete. We can see. So there is a rainfall. There is a number of umbrellas sold. So if I wanted to see the the how these two variables are related, the first thing which I will do is go insert and plot scatter plot and see. So how they are scattered, right? So I have scatter plot for number of the rainfall against the number of umbrellas sold. Okay. So now I'll select. They are not linear. Are you seeing any line? No, they are not linear, right? I'll select these data points and I'll try to add a trend line. Trend line, you can see where you can put exponential, you can put linear, you can put logarithmic, so on and so forth. Here our regression is linear regression. Okay, so I'm selecting linear and then I'm clicking on display equation on the chart. This is my equation of the line. Okay, this is my equation of the line, and we are going to look into the equation of the line. So 0 point, nothing but y equals to 0.4739 x minus 14.9951 as my intercept. This is my equation of this line which we have defined. Okay. So what we will do, what we will see. So just imagine simple. I'm using I so this is nothing but where we will see whether the what value we are going to look based on this equation equals to our rainfall multiplied by the 4.739 0.4739 plus or minus 14.951. This is what we have predicted. Okay. Okay. So number of so instead of by following this, what we achieved, we if the rainfall is 82 millimeters, then we predict that 23 umbrellas will get sold. But the actual value was 15. Since it is following the linear equation, there will be an error. So we need to minimize this error. Now, without getting confused, we will take a small equation here. 10, 20, 30, 40, 50, and this is, so it is a simple equation. It will follow insert and then charts. So it's in very linear mode. Trend line and see automatically display equation on chart. It is very simple. Y equals to 0.2x plus 1. Okay, 2 times, if you multiply 0.2 times of x plus 1, the value will come. It is very much linear, right? If I add 60 here, okay, what will be the number? By following it equals to this multiplied by 0.2 plus 1, 13. Okay, so this is a linear equation. So here everything is linearly implemented, whereas the values are scattered. So nothing is in a right flow or linearly represented. So this is the error which we are seeing when we predict. Now, how do we do the same thing? We are going to do it using our um, Excel data. Go to solver. If you do not find solver here, go to your file and go to account. Sorry, go to more, then go to options, and then there is a quick access toolbar, and there are something it will ask there is add-ins. So if you have Excel add-ins, then solver add-in I've already added, analysis tool pack solver add-in. If you do not add, you can click here, you can click go, then you will see that I've add-in over here. I'm clicking on solver. In solver, sorry, in now I'll click on data analysis. In data analysis, there are several things you can see: correlation, covariance, variance, descriptive statistics, so on and so forth. Click on regression and click on OK. Then you will see my y values. What is my y value? Y value is the independent variable, which is rainfall. Sorry, dependent variable, which is my output variable, my umbrellas, number of umbrellas sold. And the next value is my number of rainfall measured in millimeters. I have added labels because in the first row we have labels, and then output range will be on new worksheet, I have added residuals, standard residuals, residential residual plots, so on and so forth. Click on OK. You will get these things. Okay. What did we see here? There is something called coefficient. Do you think the value is same? 14 point minus 14.951. Yes. And rainfall, the coefficient value 0.4739. Is it the same? 0.4739. So if you add a trend line over here, this is nothing but the regression line. Okay, this is the closest possible regression. See the errors, difference between the predicted value and actual value. There is an error. If you see, that is the error. Predicted value 23.942, residual value is 8 point minus 8.94912. See, this is as close to what we get it. Okay, this is very simple way of understanding linear regression. Let's go and see the same thing in our Tableau. Sorry, in our Python, and we will try to see. So Python, here we are trying to see what kind of libraries we are going to import. NumPy as NP and plot to plot our values, and then linear regression, the sklearn.linear model, import linear regression, and train test split. Okay, so what is train test split? Here we have taken till here. This is the test data. Now I will put 165. Okay, automatically the value came here, right? Based on the equation. Okay, so this is what we are going to test. Okay, here I have created. I have not created the same thing. Whenever you don't have any data, you can generate. The beauty of Python, NumPy or any random function is to generate synthetic data. We can create our own data. Here, our data is rainfall. It's following 100 times. The rand variable, random.rand gives bit number of this 50 is total number of samples you want to generate, and 1 is each sample. We are going to generate between 0 and 100 because 1 to we have to generate 50 samples and we are generating 1 to 0 to 1 multiplied by 100. Okay, so the values ranging from 0 to 100. 50 values we have created. And again, rain umbrella sold 0.5 times rainfall plus 1 plus some error. So this is the some random equation. Random number we have to generate umbrella sold. And now let's run the very simple thing. We are running. Okay. Yes. The first thing what we did is to see the distribution scatter plot between umbrella sold and rainfall. You can see 50 data points are here. Fine. Now I'll close this. Automatically something else will come. What is that? So here I just kept for my understanding whether the values are number of shape of this x and shape of y are fine or not. Otherwise you will see some errors. So I've created train data, test data for both rainfall and number of umbrellas sold. Test size 0.2 means 20% of my total number of data points. So I have created, if you see now I will plot this 50 data points. Now I have 10 data points randomly selected over here out of this 50. So 40 training data and 10 test data, and my linear regression line is like this. Okay, this is the output. So what did we do? We have created this, and then model equals to linear regression. Here, whichever the model you want to define, you are going to create model is linear regression. And this model linear regression, it will take dot fit our x-axis, our x variable and y variable. Okay, number of independent values and dependent value. And so this is how we will predict predicted umbrella sold, model dot predict umbrella sold. Okay, this is what we are going to see, and we are going to look into the this is what to look into the output over here, and we are going to see the linear regression example plot over here. Okay, I'll close this. And what did we do after that? I have printed Coefficients and intercept. Model dot coefficient, the slope and intercept over here. 1.00741 742 is my intercept and coefficient is 0.495. Okay. This is, if you see this line, 0.5 plus 1 plus some noise. It is as close as we can get it. We have kept based on the same intercept my 143.6 as my number of rainfall in millimeters. It is being predicted the value as how much? 72 umbrellas. That's it from linear regression side. We will look into the logistic regression now. What is logistic regression? So we have understood regression. I hope it is clear now. And if you have any doubts, please put comments over the under the video, and we will look into the classification side of it. Classification, the other technique, machine learning algorithm under supervised learning. So again, here the objective is to classify, which means it is not a real value, which is a categorical variable or binary variable, which is simple example over here is churn classification using logistic regression. So whether the user gets churned out or the user will stay in the company or in the organization or not. So for that, again, another simple program, same thing. So I will explain the difference between linear regression as well as logistic regression. Here, same import numpy, pandas, and again test and train split. Instead of linear model, we are going to import logistic regression. Instead of linear regression, we are going to import logistic regression. So you see the difference here, right? Whereas here, we need to identify accuracy score, confusion matrix, and classification report. Don't get confused with confusion matrix. I will explain in simplest possible terms. So again, we are instead of synthetic, we are creating synthetic data, simulate customer churn data set of 1,000 samples, where these are the random features. We think that age, tenure, monthly charges, these are all other things for a specific customer's characteristics. So here is the important thing, churn probability. So can you see this? The function is nothing but 1 upon 1 plus e power 1 equation. This equation is nothing but a weighted sum of the independent variables and their coefficients. Here we can see y equals to 0.5x plus 1 plus noise, whereas here we are seeing same value 0.05 into age, here x1 plus 0.1 into x2 plus 0.002 into x3 plus some noise. Okay, this is nothing but 1 upon 1 plus e power minus z. That is the probability function. And we are churn label we are creating where if the probability value is greater than 50%, which is 0.5, greater than 0.5, then mark it as 1, which means they are going to churn, and less than 0.5, then say they won't churn. So here the label is binary. 0 to 0 means not churned, 1 means churned. We have created these four labels. We created a data frame, and we have split again this into x and y variables. Same thing we did here. If you see here, rainfall train, rainfall test, umbrella sold test, and umbrella sold train, we are splitting them into the same way. And the test size is 20% of these variables. We have 1,000 observations, 20% of 1,000 is 200. Okay, and instead of the linear regression which we have created, here we are going to put logistic regression. Then we are going to put model fit, and based on these train data set of 800 observations, and then we predict based on the test data, and we are going to see what are the accuracy matrix, confusion matrix, and classification report. Okay, you see we have our classification. Logistic regression says 97% accurately classified that either they are completely churned, either they will churn or they will not churn. Okay, and we have all these scores which is available over here, right? This is nothing but this is how we classify whether a specific user is going to be churned or not. Okay. That is power of classification. We have simple sample real world simple use cases. House price prediction. Again, you can prices are real values. You can use linear regression, financial forecasting, demand forecasting, so on and so forth. Okay. Credit risk assessment, when we say whether the user is going to defaulty or not, right? Academic performance prediction, whether student is going to fail or not. So like this, you can use both for classification and the regression test cases over here. I hope you understood these differences and concepts. So our next steps, again, we are working with the math behind the concepts, machine learning fundamentals, and going forward, we are going to understand the unsupervised learning, where you will see k-means, the neighborhood, other techniques and tools, and we are going to understand we'll take a big data set and we will pre-process the data set, and we implement data visualization techniques, and then we will get familiar with big data tools and technologies, and we will solve a real-time problem with the data which we get it from the database sources. We have several database data sets which are available in Kaggle or in UCLA, in other different sources. So please ask me, please put a comment if you need those kind of data sets, any problems which you want to practice, if you want to have any help from my side to understand any concept or any coding issue, please reach out to me. So thank you so much. Please follow the Datavedha LinkedIn page and my website, and please subscribe to this YouTube channel for your futuristic questions and answers. Thank you so much. Have a great day. Namaste. Bye bye.